Hello, and welcome to The Missing Piece, the ocean's role in net zero carbon. I'm Dr. Paul Snellgrove, the Departmental Science Advisor for Fisheries and Oceans Canada. I'm a professor of ocean sciences and biology at Memorial University, and I'm also the Associate Scientific Director of the Ocean Frontier Institute. Scientists have done a good job of getting the word out about the importance of rainforests, and more recently, northern forests, in carbon uptake and climate change. But most people don't realize the critical role the ocean has played and continues to play in carbon uptake, the price the ocean has paid for providing that service, and the implications of that contribution for Earth and for humanity. And what does the future hold? Can we even say? The ocean takes up carbon through biological processes, but also through physical and geochemical processes. And that uptake has implications for ecosystems, including humans, as apex predators. It also has ramifications for net zero carbon aspirations and the role of the ocean in the net zero carbon equation. If we're miscounting one of the key carbon variables, or if the contributions of the ocean change, then we may not be able to solve that equation and achieve our aspirations. Now today we have three excellent panelists who will take us through this complex story of the missing piece and what it means for life on Earth, including us. Dr. Anya Waite, the Scientific Director of Ocean Frontier Institute and Professor of Ocean Sciences at Dalhousie University, will start with the base of the food web and how that links to ocean carbon. Dr. Emily Choi, the Lorient UNESCO and NSERC postdoctoral fellow at McGill University, will take us further up the food web with a particular emphasis on seabirds. And then Mr. Ken Paul, lead fisheries negotiator and fisheries research coordinator for the Wolastoqey Nation in New Brunswick, will discuss some of the implications for humanity and most especially Indigenous communities who rely so heavily on marine resources for their food security. Anya, would you like to get us started?
Thanks very much, Paul, for that nice introduction. I'm going to start with talking about how urgently need to understand the role of the ocean in carbon uptake. And in fact, if we link ocean carbon observation to effective climate targets, we risk not being those targets. So as many know, land-based emissions, the targets that we are setting for those, the net zero targets that for 30 or 2050, depending on the nation, actually in many cases fail to recognize that the ocean does most of the carbon absorption. In fact, already been absorption by carbon going into the ocean itself and being carried down into the deep sea. If we're actually going to get to limiting our warming to 1.5 degrees, however, we need to know whether or not this is going to continue. And there is some signs that it will not continue. So 40% in the ocean now, and the rest, most of the rest has gone into the atmosphere. We don't think so. So a critical step is to link ocean carbon observation to these climate targets. And that means really doing a step change in how we observe the ocean. We're a global ocean observing system, which I co-chair, to coordinate long-term and sustained ocean observation, talking about inputs and requirements for the systems, actually deploying the with the data products, and trying to organize delivery of services and but we're not good at all these things. They're not all well linked. And certainly at a global scale, they're happening by individual nations, not by a global system, which is actually what we need. However, what's good about the situation is that the global science community is very mature and ready to act. They have recently published a number of major documents indicating how we can take this work forward. We also know how to design observation systems. So the community is actually very action, sustained carbon observations. Philanthropists, to our governments, and to foundations, the ocean is missing in your climate targets. We raised awareness of this through the G7 Nature Compact earlier this year and did a concerted effort to bring this message to COP26 and momentum for reaching our climate goals was intense and in fact extremely uplifting. So we want to add the ocean to solve. What do we do in Canada? What's the Canadian policymaker correct action? I think that we should be focused Ocean as a global exemplar. As it turns out, the North Atlantic actually absorbs 30% of all the carbon that oceans absorb. It's right in our backyard. We know how to observe it, and it would be a good place to start to bring together these really major international step change so that we can get there. We need to think of it a little bit more like an ocean space station, where we're actually bringing nations together to solve a major global problem together. The North Atlantic Carbon Observatory could bring together observation on these very complicated systems. On the left, you see an actual observation from a satellite. On the right, you see a model. You can tell they're both getting at the same thing, but they don't actually reflect each other perfectly in any way. We also need to link ocean carbon observation to the new innovations that are happening in what they call carbon dioxide reduction. So there's a whole lot of innovation, very interesting technologies being developed to take up, artificially increase the amount that's taken into hard material and then sunk into the deep. This is a wonderfully active area. It's a very exciting place. Urgently needs a baseline. It needs a credible baseline against which you measure the carbon dioxide that you're actually taking up before you claim your carbon credit. These things, we are not going to be able to reach our climate targets. And I will stop there and just mention that the Global Ocean Observing System, as does our institute, the Ocean Frontier Institute, and we'll be happy to take any questions either by email or on this chat.
Emily, would you like to take it from there?
Sure. Thank you, Paul. So I'm just going to share my screen. So for today, I'm going to be talking about the role of Arctic marine predators in monitoring Arctic climate change. And to begin, so for my presentation, I'm going to be sharing with you some photos of the Arctic. I find that a lot of people have never been to the Arctic, so it's always nice to show people what it's like to work there. So there's several characteristics that make thick-billed murres an ideal sentinel species for monitoring Arctic change. They're the most abundant seabird in the Canadian Arctic with a circumpolar distribution. They're highly specialized for Arctic environments. They forage exclusively in waters 8 degrees Celsius and colder. They also forage off of sea ice. And they're long-lived with a low reproductive rate. So on Coates Island in northern Hudson Bay, we've tagged birds as old as 38 years old. And once adults reach 3 to 5 years of age, they will raise 1 chick per breeding season. And finally, they are an important traditional food to communities in the north. So on Coates Island in northern Hudson Bay, Nunavut, there's a colony of about 30,000 breeding pairs of murres that nest on the cliffs of Coates Island. They arrive around mid-June. They begin to lay their eggs around early July. And then once the chicks hatch, they will fledge during the first or second week of August. Now, while these birds spend their summer on Coates Island, they actually they spend their winter off the coast of Newfoundland and Labrador. Next 30 years, the diets of murres has shifted from about 50% cod to 50% capelin with the warming of Hudson Bay. Now, this shift is believed to have caused a decline in chick growth rates. So murre parents will bring back 1 fish at a time to their chicks. And because of the smaller body size of capelin relative to cod, it's believed that this shift has caused growth based on long-term monitoring data. In addition, there have been reports of murres dying on their nests due to heat stress. So murre parents will each spend 12 to 24-hour shifts incubating their nests, sometimes in full sun. And there have been reports on warm weather days of murres dying on their nests due to heat stress. And in fact, some of the work that I did for my postdoc examined the heat tolerance of murres and found that they were one of the most heat intolerant species of all birds, and in fact had the lowest evaporative cooling efficiency, which is important to dissipate heat, ever reported in a bird. So these Arctic marine birds are incredibly intolerant and poorly adapted to heat stress. And one of a major challenge is that many Arctic species, including marine predators, a lot of the thermal physiology research is focused on cold tolerance and not heat tolerance. For my PhD, I worked on beluga whales in the Nunavut settlement region of the Northwest Territories. So this is some of the pictures of the Mackenzie Delta. And similar to thick-billed murres, there's several characteristics of beluga whales that make them an ideal sentinel species for monitoring Arctic marine change. They're the most abundant Arctic odontocete with a circumpolar distribution. They are highly specialized for Arctic marine environments. They lack a dorsal fin, which helps them to navigate under sea ice. They're long-lived with a low reproductive rate. There's whales and within our study population that can live beyond 60 years of age. And females tend to have 1, sometimes 2 calves every 3 years. So this is a photo of a pod of beluga whales, and you can see the little gray whales are basically calves with their mothers. Now, in the Beaufort Sea, over the past 20 years, the inferred growth rates have declined over time within the Beaufort Sea beluga population based on long-term monitoring data. So basically size at age. And it's believed that this decline has been change. So through my PhD project, I worked in collaboration with communities in the North as part of a beluga community-based monitoring program to monitor the health status of beluga whales. What my research found was that in years of low cod abundance, the whales were switching to capelin, a warm water species. But in addition, the body condition of the whales was highly correlated to several indices of physiological parameters of diving, so that the whales that were in better condition had higher oxygen storage capacity and were better equipped to dive. So those are some of the impacts of environmental change that we are seeing in marine predators. And my work with the belugas was part of a community-based monitoring program. They are, again, an important traditional food. They have been for many, many years. And so many of the communities are very, very concerned with the impacts of climate change on the Beaufort Sea population. So that's, I'd be happy to answer any of your questions at the end.
Great, thank you, Emily. And that sets it up nicely for Ken to share some thoughts. Clearly some very dramatic changes happening in northern ecosystems with some very serious consequences for the upper food web. So Ken, would you like to share some thoughts?
Yeah, so I spent a lot of the last, 10 years of my career advocating directly for First Nations. I'm very familiar with all of the Atlantic communities, all the way up to Labrador, and a number of the communities in British Columbia. I've done quite a bit of work out there as well. And one of the things that I think is, sort of common as I've traveled around is, as I'm working with these coastal communities, there is a concern and a belief about the whole impact of climate change. When you're living in these areas that are very open to the ocean environment, you're very susceptible and sensitive to changing the impact of changing climate, changing seasons, the shortness of the sea ice season, the more violent storms and waves. And to try to bring our Indigenous communities into these science talks is a challenge. It's something that has a little bit more intense the last couple of years, I will say. I know that there's federal legislation now within Canada that talks about the inclusion of Indigenous knowledge. There's a lot of interest in trying to work with Indigenous communities, but a lot of people have a hard time trying to figure out, first of all, how to do it. Secondly, kind of trying to that Indigenous communities would play. There is the concept of Indigenous knowledge. There's a lot to that, actually. I know it's a simple type of phrase, but there's more to it than just information. There's a value system in place there. It's a knowledge system that requires repeatable kind of methodologies in order to understand. And although we're living in generally in Canada in a modern society, like this methodology is something that has sustained these communities for thousands of years. The thing that I think would be kind of important to advocate when we're talking about ocean science and how to include Indigenous communities, keep in mind that these communities are spread out all over the coasts, all the way up through the north, all along the Atlantic and Pacific coast. So right there, you have communities that are dispersed and not centered in urban areas, like most of us living in like Western society. That's important. The second thing that's important, and although there is a level of sophistication that's coming to these Native Indigenous communities with respect to programming such as the AROM program from DFO, some of the tribal councils that are investing in remote sensing, GIS systems, and other kinds of observation systems. One of the things that is also like a value that we should be using, since we're talking about observations, is working with the Indigenous communities to find out, you know, some of the legacy information, like how has things changed over the past generation? Because monitoring the rate of change of the changes in the seasons, the changes in migratory patterns of like bird species such as Canada geese, fish species such as capelin, Atlantic salmon, American eel, and these kind of things. This is all part of the information that would help us understand like where thresholds should be, and will give us benchmarks as we are trying to mitigate some of the problems that are plaguing us today, such as all of the rain that's happening like right now in British Columbia, as they are now the front lines of what's happening to climate inaction. They went through a whole heat dome problem last summer with the third, I guess, on the third largest forest fire, number of forest fires on record. And now they're suffering from torrential rains through atmospheric rivers that are literally wiping away highways, communities, and, you know, really jeopardizing, putting a lot of people in danger. So like I think it's kind of important to try to work with Indigenous communities, even though it may not be immediately intuitive. I think that what people will find when they build these relationships and work with these communities, they actually have a lot to contribute to help us understand like what's going on in our ocean environment. So I just wanted to share those comments for now, and just pass it back over to Paul.
Great. Thank you so much, Ken. Appreciate all of your presentations. Very different perspectives, but I think giving us a very holistic view of some of the different challenges associated with climate change and understanding climate change. I don't know if we've lost Anya. Her screen has gone blank. But perhaps while we figure that out, Ken, I'll throw a question back at you. I did want to tell our audience members that we have a discussion forum. So far, I'm not seeing any questions in there, so I'll throw one or two out to see if we can't get things rolling. Ken, we heard Anya advocate for a North Atlantic carbon observation system. What role might Indigenous groups play in such a system, and why must they play a role in such a system?
Well, Indigenous peoples, even within the name itself, like indicates that they are from the lands. They're from the lands and waters. They, as I've mentioned, there is a lot of like, I guess, information that is within the traditional harvesters within the area. Some of the older people, the elders within the community, they have information. It's just that we often have a hard time accessing that information because we don't understand the context. We don't spend enough time to really gain the trust. But I'll say that Indigenous peoples, and especially our knowledge keepers, want this information to be shared out. Like they're as concerned as the rest of us about what's happening to our planet. And what I have found is that when an Indigenous community thrives, all the other communities surrounding it also thrive. The location of these communities is also really important. So depending on what type of observation stations one might set up, and I know there's an increased reliance upon satellite imagery, satellite observation stations, but there is, I guess, still a need to have land-based observation stations as well, so that they can we can have like maintenance on them, because we send something out in space, you may not be able to fix it from here on the planet, but if something is close to a community, there you can have technicians in place actually on the ground to help do this. That would require some training, that would require partnerships with the Indigenous communities, but to increase that capacity, I think is also, I guess I'd say a little bit of a social justice system, a social justice kind of thrust from Canada itself. And really it's beneficial for everybody if there's investments, whether it's being science or technical knowledge investments into Indigenous communities to help bring together like other perspectives and other points of view from resource users. So that's sort of how I kind of think about these kind of situations when I think of hardcore technology with respect to our coastal communities.
Excellent. Thank you, Ken. Anya, we've had a little bit of a technical glitch. Can you hear us now? I think not. So I'll throw a question over to Emily. Why should we work with northern communities? Why is that so important for scientific research and for knowledge generation?
Well, yes, I believe like for Arctic work, it's so important to work in collaboration with northern Indigenous communities. For my PhD work on beluga whales, I would not have had any tissue samples if I had not have had that partnership with the harvester camps in the Nunavut Summit region. You know, a lot of the questions that the scientists have asked are guided by the communities. And in fact, a lot of Indigenous traditional knowledge or Inuit traditional knowledge helps to guide the science. For example, you know, the long-term decline in inferred growth rates that I talked about that had been published based on the harvester data. Well, before that was even published in a scientific journal, the community members had been telling scientists for a long time the belugas were getting smaller, the belugas are getting smaller. So before we've actually put, you know, the data together to find the trend, the northern communities already know that these changes are happening, you know, to the belugas. In addition, you know, for the past, you know, 2 years of COVID, you know, I haven't been able to go up to the Arctic, and so a lot of the scientific research that has been continuing has been the work that has been done with the communities and has had basically northern communities collecting the data to monitor climate change. So yes, I believe that the communities have an important role and will continue to have an important role in Arctic science.
Great, thank you. I'll have a question here for both of you. I'll start with Emily, which is, why is Arctic monitoring so important? Why do we really need to do it?
Well, the Arctic is basically considered an early warning system for the effects of climate change, you know, across the world. You know, many species, such as, you know, the thick-billed murre, are considered canaries in the coal mine. You know, they're so highly specialized for cold climates that, you know, the fact that the Arctic is warming at twice the global rate makes these species highly vulnerable for the effects of climate change. So it's known as an early warning system for some of the impacts of climate change that could happen in the southern hemisphere.
Excellent. And so Ken, why do you think that monitoring is important for Indigenous people?
Well, similar to what Emily was talking about, like the changes in migration patterns of species, and you know, specifically, I work in the realm of fisheries. We're very concerned about what's going to happen with the food security for our nations along this area. Like, for example, right now there is an abundance of lobster in our area of the North Atlantic on the East Coast, but if the Gulf Stream current keeps pushing more and more northward, and keeps pushing the Labrador current out of place, then these waters are going to get warmer. And their lobster are kind of like a lot of other species that they like cold water better. So there's a concern about what would happen to the larvae, lobster larvae, as they start forming in the areas of the Bay of Fundy. We have seen other species show up in our waters that have not been very prevalent in the past, such as sharks and things like that. But the traditional species that we would see here, such as American eel and Atlantic salmon in particular, we know they're threatened in these areas. I also know that there have been, I have friends from the Northwest Territories who have told me it was last winter, a year ago, like they had Chinook salmon show up in the Mackenzie River Delta system that never had shown up there before. So they're having problems with the migratory routes of Pacific salmon on the Pacific coast, that instead of coming down the coast and occupying the rivers such as the Skeena and the Fraser, in areas on the north coast, that they're actually going around Alaska and coming up through the Mackenzie. So it's okay, I guess, to welcome these species inward, but there will be an impact on the native species that are there. And once you start dealing with this imbalance, if this imbalance, it'll start impacting other things such as plant life, sea bottom viability, and other kinds of like spawning areas. So that's one of the most important things. Another thing that's really important is that many of our communities are coastal communities. They're literally built on salt water. And as we have sea level rise, coupled with increasingly violent storms, because these communities are in very, there's concerns that within the next 30 to 50 years, that there's going to be widespread damage, like basically environmental refugees within their own home territories. So this is another thing, and walls, and we can engineer other kind of breakwaters to try to hold back the sea, but those are temporary solutions. The longer term solution is to try to mitigate like what's going on globally and within our communities. Like they want to participate, they want to take their part, and hopefully the patchwork of everybody doing their work together will help slow down what we are seeing as happening in climate disasters.
Great, thank you. Anya, we've been discussing the importance of monitoring, both from a scientific perspective directly, and then also from an Indigenous perspective. I was going to ask you, what role ought Canada to play in any sort of North Atlantic carbon observatory, and what role should Canada play in such an activity?
Well, thanks, Paul. I did catch a little bit of Ken's comments. I think it's absolutely critical that we have an understanding of these massive changes that are occurring in the ocean and how they're going to be impacting our communities, particularly Indigenous communities. And I think we have essentially two separate roles. One is to monitor our coasts and our continental shelves well enough to support communities going forward under climate change. And the other one is to step up into the international arena with something akin to this space station concept, where we work on the high seas with numerous other nations together and bring the weight of the observing nations together and allow nations that aren't observing nations to contribute and both to the conversation and to the construction and support of an observatory. And I think that there's lots of potential for Canada to bring an Indigenous perspective to all of its international conversations. One of the things I noticed, the Department of Fisheries and Oceans organized a number of workshops for the UN Decade of Ocean Science for Sustainable Development. And one of the key issues that kept on coming up when they were asking the participants, well, what can Canada do? What's Canada's unique role in the UN Decade, for example? And many participants focused in on Indigenous issues, saying Canada is uniquely placed to raise these to the international stage, has done so in the past. There's some other nations who are also, in this conversation, but Canada, because of their very extensive coastline and because of the number of Indigenous communities that are right on the coast, has, I think, a very, very special role and can really step up in a leadership capacity here to do, take the first steps to bring this conversation to the international attention.
Great. We have quite a shy audience today. I've been watching the live Q&A and the discussion forum, and no activity there, but that's fine. We're having a good discussion so far amongst ourselves, but certainly welcome questions from the audience. Anya, I was also going to ask you, certainly Canada, from a geographic perspective, has quite a unique role to play in carbon observation. It's one of a very few places around the world. There's several others. Perhaps you'd like to say a little something about that, including the other global locations where they're real hotspots, if you like, for carbon cycling.
Yeah, look, one of the big issues we have is that not all parts of the ocean absorb carbon equally, and those hot spots are changing and morphing, and we really need to know what's happening there. So the North Atlantic, for example, is a very special area because of the formation of deep water. So the surface ocean cools and sinks thousands of meters down to the bottom of the ocean, carrying with it this kind of large sort of charge of carbon that is accumulated at the surface. And that system is, part of the reason that the North Atlantic actually absorbs 30% of the global carbon absorption. So that's the North Atlantic, as we know, and particularly east and west of Greenland, so the Labrador Sea, and then some of the areas going up towards the Arctic gateways are very, very important for carbon absorption. Some of the other areas include the Southern Ocean. Now, the Southern Ocean is a really interesting place because it's simply so huge and so hard to measure. And for many decades, the Southern Ocean was seen as the biggest sink on Earth. First of all, because it was so physically big, but also because it had these plankton blooms that grew in bands in the austral summer and then sank with their load of carbon down to the deep ocean. So this was considered to be the critical place for carbon absorption. And then some of our colleagues put some floats that measured carbon into areas south of the polar front, so closer to the Antarctic, the actual continent than had been ever measured before. And those are areas where there's something called upwelling, where the ocean lifts up towards the surface. And what they found there was massive outgassing of carbon dioxide. And so pretty much overnight, with one set of measurements, the Southern Ocean went to the biggest sink in the world to being seen as a source. And then the most recent measurements and numbers have suggested that actually the Southern Ocean is a small sink net, right? So a big absorption and big release, meaning a slight net sink. So I think what that shows is just the massive uncertainty. And we say in the observation community, we call it when an area is critically underobserved. It means you simply do not have enough measurements to tell you what's going on. And we really can't afford this as we go forward to, we're putting a lot of pressure on oil companies. We're putting pressure on all our businesses. We're putting pressure on governments, saying we have to get to our climate targets. But if the ocean is plus or minus 30%, or plus or minus these huge amounts where a few measurements here and there can change it from plus to minus, or from a source to a sink, we are nowhere near being able to support that level of land-based effort to get us to net zero. And so it's absolutely critical that to keep ourselves credible, that we measure the ocean well enough that we can say, okay, we can support these strategies on land-based net zero because we understand the ocean well enough. And the thing is, Paul, the ocean community, I guess one of the points that I like to make here is that we can resolve this. We simply need to up our observation intensity. We know how to do it. We know exactly what to do, and the community is well poised to do it. So it's just a question of bringing the effort together to actually execute. And when you think that all our efforts to get to net zero could potentially fail because we don't have enough ocean data, and you're spending trillions to get to these climate targets, it's actually not a big ask in that context to say, let's resolve the ocean carbon sink to plus or minus, let's say 5%, so that we can actually support the land-based work with a strong baseline.
Great, thank you. Emily, a question for you. Many of us do not live in the north. I'm here in Newfoundland. I know you're in Gatineau at the moment, and Anya and Ken are there in Atlantic Canada. Why should the rest of us care? I mean, other than being caring people, but why is it important that we understand these changes and try and do something about these changes?
Oh, well, again, the North is considered an early warning system for the impacts of climate change across the world. And as I mentioned, based on my research, there's a lot of species such as thick-billed mares that are feeling the effects of Arctic warming, and that we've found are quite sensitive to heat stress. And this past summer we've felt this heats the impacts of Arctic warming have been felt in the Arctic. The Arctic is warming at twice the global rate, and this past summer we've had several basically heat events. So there's several effects of climate change that are occurring in the Arctic are going to be likely seen in southern regions, such as world heating events too.
Great, thank you. I have a question. I'm going to put Ken on the spot a little bit here. I was in Maine a couple of years ago, and I was quite struck by the importance of ice for the very lives of northern people, not simply because of the interaction with the animals themselves, but simply in their existence. Did you want to say a little something about that and its role in transportation, in livelihoods?
Yeah, so I have spent a year up in Inuvik in the Western Arctic, in WT, and I honestly, I did think I knew Indigenous issues in Canada until I moved north, and I learned a whole bunch of things that I actually didn't know. One of the things that's really important to northern and isolated communities, whether you're talking about the Northwest Territories, northern Manitoba, northern Saskatchewan, is that ice is seen as a reliable surface. It's I know that there's communities right now in northern Manitoba, because I have friends up there, that the ice hasn't settled in yet. So they have actually transportation issues. They can't get goods and services up there right now. And when northern peoples go out on the land and onto the ice, they need a predictable ice surface so they can see like wind patterns, weather patterns, and that helps them with their own navigation, their own systems, because electronics don't tend to work very well up in those northern climates, especially in the winter when it goes down to -30, -40 degrees. So having a solid, reliable, predictable ice, you can see the wind patterns off of the snow drifts that are there, and it can help people not only get around but also try to figure out where they should be going out to find food and water resources in those northern fields. Transportation, that part of it is really important because there's a number of goods that you can't make in the north that people rely upon, and they have to be shipped up there. Now, if you have areas where there's open water, then yes, you can use water vessels. But a lot of areas don't have that. And also, if it's not a good solid freeze, then they can't rely on these ice roads to have trucks and other vehicles ride upon them. If it's not a solid freeze and it starts breaking up early and stuff like that, they call it rot ice, and it's very dangerous, and it has a tremendous economic impact on the north. And because to try to bring things by air, because that's the other option, is so expensive. It's expensive because of the fuel, the type of vehicles that you need to bring in, whether it's on airplanes or helicopters, and also can be quite dangerous because the weather is so unpredictable in north. And you might be a sunny day, but once you take off, like that weather system could change on you quite quickly, and it's so dangerous. Having that predictability of solid ice is so critical. I personally like the cold. I like the winter to be cold because then we can actually do things outside. It's when it's kind of like not quite cold, coldish, stuff like that. That's when we have like seasonal problems with depression and things like that as well. So there's a whole mental aspect of this as well. I mean, that's just my opinion. I'm not an expert on these fields, but this is just sort of what I've experienced and what I've observed.
Yeah, no, that's very helpful, Ken. Thank you. I mean, certainly a very serious issue for local residents. Also a real challenge for trying to get scientific data. And we've alluded to the importance of local observation, because getting ships up there when there is ice present and then during the breakup is extremely complicated. And so of late, one of the tools that scientists have started to use working with Indigenous groups is snow machines, and basically drilling through the ice in order to get information on what's happening beneath. We do actually have a question now from Mathieu Rioux, who has asked about issues of Indigenous data sovereignty and that whole issue of data ownership and data sharing. Perhaps, Ken, it would be appropriate for you to start, but we'll also hear from Emily and Anya after you speak.
Yeah. Data sovereignty is a very important and live issue, especially since there's some Indigenous knowledge. There's always been a lot of researchers that have come to the Indigenous communities, have talked to elders, gained information, but unfortunately the history of this process is oftentimes the benefit never went back to the communities. And there are also times when information that was shared out was actually used against the Indigenous communities when talking about land claims and settlements and treaty negotiations and things, because the research wasn't done properly. One of the things that I've been advocating quite strongly for the past 5 years is this whole concept of developing protocols that rest with the Indigenous communities, so that when visitors come in, when researchers come in, there are people in place that can actually work with the researchers to try to understand what the intention of the researcher will be, try to negotiate mutual benefits, and then to also work with the community knowledge keepers so that there is a way to do it respectfully, potentially do it in the language to make sure the information that's shared out is not taken out of context. And also, like, if there's investments along this as well, it will help the Indigenous communities manage the information. Because when you talk, I know when I've spoken to elders, if I ask them a question, I might get an answer that goes far beyond what I am actually really seeking. But all of that other information is so important, and it can help with so many other things, such as community planning, management plans for resource extraction, planning for governance and things like that. So, but the communities do need investments to start developing and technicians and start purchasing databases, to also be able to invest in equipment such as drones or accessing satellite information, geographic information systems, all of these other technical needs in the communities to help them, I guess, maintain pace with what is going with a lot of their research institutes.
Excellent. Thank you. Emily, did you want to add something to that?
Yeah, sure. So I haven't worked specifically with Indigenous traditional knowledge, but as part of a community-based monitoring program, before I even started my work as a PhD student, I went to the communities, I consulted with them, I met all of the hunters and trappers organizations and the hunters that before I even started my research, I got to know the members of the communities that I'd be working with. And a really key part of my program was the constant communication. So although in the summer I was living at the harvester camps as part of the community-based monitoring team, during the winter I was often in Inuvik or Tuktoyaktuk giving presentations about my research or the results that I'd found so far, going to kind of basically community groups, game council meetings, schools. And so there was a constant communication. And for any, scientific results or discovery, we made sure that the communities were the first to know our results. So they were always aware if we were publishing anything, but they were always the first to know when we had results. And at the end of my PhD, we actually had in 2016 a Beluga Communication Summit. And so this was basically all of the basically the hunting camps and across the Sub-Cinnamon region and Polytuck. I was at Kendall Island, but Hendrickson Island and what are the ones? East Whitefish were all invited, as well as other communities, to basically get an overview of all of the research that had been done as part of this program over the past 5 years. So again, one of our goals is to constantly communicate with Indigenous stakeholders. And if we have any key results, they're the first to know before any publications or news knows of it. And we always ask permission too, as well.
Anya, thank you, Emily. Anya, anything to add there?
Yeah, just listening to Ken and Emily's comments, and I think, just following on from that, not everyone has the experience when they start, and so to try and encourage researchers, particularly working in Indigenous communities, to start the right way. We worked on something that we've called the Indigenous Engagement Guide, which is on our website. Basically gives, it's particularly focused on Atlantic Canada, but most of what it says is also relevant for other areas. And it basically just gives researchers a kind of an introduction to what types of things you might need to think about long before you're thinking about your research, if you're going to be working close to areas that are important to Indigenous communities. And I think we're just starting from such a low baseline in some of these areas. One of the aims that we've had is to bring the baseline up by having every single person doing ocean research, whether it's a computer programmer or a lab dishwasher or somebody who's actually in an Indigenous community, the whole spectrum. Actually, we have Indigenous training that that is available to everyone, and it gives a background on the history and some of the cultural richness of Indigenous communities in Canada. And again, just raising the baseline a little bit so that all the researchers, anyone involved in ocean research, actually starts from there, not from there. And I'm not saying that this is, huge, but it's a place to start, and we're happy about it. We have a committee of 8 or 9 Indigenous advisors who help us with the decisions and the work we do. And we've also launched one of the largest programs of its kind in Canada. It's one research program of our phase 2 project, which is really a braiding or it's an attempt to braid traditional Western science and Indigenous knowledge, and up in Nunatsiavut. So again, we're starting from a fairly low baseline. Everybody knows that, but we're trying to take a few concrete steps to bring the whole research community a few steps forward. And I think, with time, we're moving in the right direction at least. And it comes to, Marlene's question again in the Q&A there. Well, how can you convey 4,500 years of historical experience that isn't held conceptually? And I think there is no answer to that, right? Because of course you can't. But it's also, of course you can, right? So it's a question of where do you start with the conversation, and moving, I think, away from always the kind of traditional Western knowledge, which is very word-based, and closer to experiential knowledge. But I think that's a wonderful question to give to Emily and Ken.
Ken, do you want to? You smiled as Anya said, it's an unanswerable question. So let's throw it to you next. What do you think?
Well,
about
what's the question
4,500
again?
years. How can one convey? This is from Marlene Aclio, which is of historical experience.
Well, how you do it? Well, like one step at a time. I think it would be kind of important. The thing is, again, working with knowledge keepers in our community, whether they be elders or other people who have who are entrusted with sacred knowledge and have a role, there has to be in other individuals that must work with the researcher and with these knowledge keepers so that things are not communicated incorrectly, out of context. They can work at the pace of the knowledge keeper or the elder as well, because there are these subtle like social cues that you really have to pay attention to, these dynamics. And like a lot of times, the stories that we hear are not necessarily linear as well, which is something that a lot of people really don't have, really have a hard time understanding that, and why, like why are we going off in these several different directions? If you spend time with elders, you understand that it's all part of kind of like weaving an entire fabric together. You know, not just like a linear story, like a string or a rope. So it's so important for people to like. I know that a lot of people talk about building these relationships with Indigenous peoples, but I really think it's important to make that investment, especially at the beginning, because if you just come in and you kind of want something from the community and they get the sense that you're only there for a short time, then they probably are not going to be as open to sharing, even if there's monetary like exchange for the service. When we spend time with the communities and we actually listen to what their research priorities should be, because our communities have a lot of questions, and if we start from that perspective as okay, what does this community really want to understand, and what are their concerns, and then and frame our research around their work, then all of this information and knowledge will be a lot more relevant to them. And like I had mentioned before, if an Indigenous community is thriving, the surrounding communities thrive, because what benefits the communities benefits our society in general. So it's just spending time in the communities, not worrying about the end. Because also the other thing that I've worked with a lot of community-based researchers from a number of universities, and those that have taken the time that done this, what they thought was going to be a 2-year project may end up being a 4 or 5-year endeavor, but the relationship endures. And it's so much more fulfilling for them personally. It's not just about the knowledge that they are gaining from that community itself. So that's how I would approach it myself.
Yeah, very helpful, Ken. And it does illustrate a challenge. I absolutely agree with you from what I've seen. And the timeframes of research projects don't necessarily easily lend themselves to that full development, but we have to strive to do it. Emily, I'm wondering, do you have any examples of the research that you have done with seabirds and with whales, where that 4,500 years has of information, where you have managed to successfully extract aspects of that knowledge and how that shaped your studies?
Well, I mean, I agree with many of things Ken has mentioned. So, you know, working with the communities, a lot of our questions are guided by Indigenous traditional knowledge and historical knowledge, in terms of, you know, the impacts of climate change, what the belugas are eating, and contaminants, particularly as a food resource, is a huge concern to communities. I don't know, have a trend over 454,500 years, but again, that decline in growth rates before that was even discovered, so that was 20 years, that was basically this have been telling scientists the belugas are getting smaller. There were many times in the communities where, you know, we had temperatures of about 30 degrees on Kendall, and a lot of the elders had actually told me that it was unusually warm. And a lot of the housing or the cabins on the coast, on the islands on Kendall, many of the actually had told me too that every year the coastlines were basically receding, and their cabins were getting closer to the water. Some of them had actually fallen into the water. So there's many, you know, observations, or basically the communities are experiencing climate change, and they're relaying that knowledge to the scientists. But again, it is so important I agree with Ken that it's important to have these long-term relationships working with the communities. Unfortunately, as a PhD student, once my funding was up, I had to move on to a new project. But luckily, that program that I was a part of, it's co-managed by Fisheries and Oceans, but also the Fisheries and Joint Management Committee, which has many community members. That has been going on for over 30 years. So that program has continued. And so I hope that once I find a permanent position, I can continue my relationships with the community members in the Nuvia-Altsum region.
Great, thank you. Ken, I don't know if you can see the questions if you click on live Q&A. There's one again from Marlene Atleo, and it's truncated on my screen. I can't see the full question, but she starts off by saying we can laugh about it to reduce tension, but in my lifetime, not a heck of a lot has happened. Can anyone see the rest of that question and help us out on that?
Yeah, a heck of a lot has happened because we don't engage in dialogue. How does science develop dialogue rather than this translation into English? It's garbage in, garbage out, says Marlene. It's not community research concern, it's about what government are interested in. We spent years in the courts, and our guys still can fish.
Thank you, Anya. Can't for the life of me see the rest of that message. I don't know if anyone would like to just raise your hand if you'd like to take a shot at that. Certainly one thing that strikes me is relationships, and building relationships is time consuming, but it's really critical in that communication, that translation of knowledge. And it certainly doesn't happen just, there's a phrase that some of you may know of, helicopter science, which may or may not have anything to do with helicopters. It's basically scientists who fly in, collect some data, and then disappear again. Would anyone like to take a shot at Marlene's question, this most recent one?
Yeah, I can make a comment about that.
Thanks, Ken.
So again, this is going back to this perspective of actually asking the communities what are their priorities, and investing in communities themselves, and spending the time in communities. What tends to happen, and I've been to a number of like science forums over the years, and what tends to happen is that a lot of the science that is funded by our governments and by industry is there to try to get a firm understanding of like what is the capacity or what is the population of a fish species in order to maximize the economic benefits. Like the end goal is about economics. And this is a problem that we have generally in our Canadian society, which drives consumerism, it drives marketing, it drives the whole global economic problem. And I know that in COP26, like this came up a number of times. However, this is where there was a lot of concessions made, because there's always this fear that we are not going to be able to maximize our economic benefits. When I work with our community members, whether I'm working in a fishing boat, whether I'm working with them in the forestry and stuff like that, one of the things that I found about our community members is this idea that they will fish and then they'll stop. And if you ask them why, it says, well, I think I got enough. I know I can fish for another couple of hours and probably get some more whatever, but I think I have enough. And I just want to make sure that there's fish there for next year or for tomorrow or for next week or for the others, right? And when I go to some of these meetings with industry people from, forestry or fisheries, those are the main two things. And I'm doing a little bit of stuff with energy as well. But they talk about, they'll argue with DFO scientists. They'll try to say that, no, our fishers out there are seeing bigger populations. You guys didn't do your surveys at the right time of year, or we should make. And there's this it's a bit of a arrogance on our society when we seem to think that we can understand like what's going on down there, and we don't tend to think from the perspective of the fish species themselves. We have migratory species. So I'm in my home territory up in the Wolastoqey territory, And we have a major river system which empties out of the Bay of Fundy, opens up the Gulf of Maine and the Atlantic Ocean. And as we're talking to developers and people that are working on dredging projects down in the city of St. John, which is at the mouth of our river, and things like that, like they always try to talk about what are we going to do with the people? Like where are we going to move the fishing boats, and where's the traffic going to be? But we never really think about what happens to these fish species that are migratory. So we're talking about capelin, shad, eels, elvers. We have some sturgeon, which are mostly the river systems, but they spend time in the bay. So if we're doing activities under the water, that noise impacts their quality of life. If we have hydro dams, of course, those are physical barriers for them trying to get home, because some of these fish species have made journeys from across the ocean to actually get here. And once they get here, like we don't have a good habitat for them. We have problems with agricultural runoff from the potato farming primarily. We have problems with glyphosate and other things that we're doing to our forests here. Clear cutting is still an acceptable practice here in New Brunswick, which washes soil into the river systems. So we are generally neglecting our duties to take care of the water systems for these species. And this is some of the heartbreak that we feel in our communities, that our elders really want people to understand that. Because if we don't have healthy fish species, we can't live. It's kind of like blood platelets in your blood system going through your veins. If you don't have healthy blood that is enriched with nutrients, then your body will die. And it's not like we're not really protecting Mother Earth, we're protecting ourselves, really, because we are the earth. Like what we do to the earth, we do to ourselves. It comes back onto us. So this whole concept of like not trusting science and not understanding science, that is prevalent through a number of our communities. But really, I think one of the bigger problems is like, what's the goal of the science itself? Is it to actually maximize economic gain? And if that is the only goal, then we are really doing a disservice to ourselves and the future generations. And again, this is my opinion, but this is what my lived experience of what I've learned from many different elders and traditional peoples and thinkers and philosophers. Because I've also found that people that are in the academic fields that are like, they've been around for a while and have thought about this kind of stuff, they actually align a lot of their views along these lines as well. So I don't know, that's just what I think.
Yeah, no, thank you, Ken. And certainly one of the dominant concepts in fisheries management has been one of maximum sustainable yield. And the idea there is how much fish can you get out at the maximum amount. And so indeed, I think there's a lot of rethinking of that these days with more ecosystem-based approaches. There's another question that I haven't gotten to yet because of this display problem I'm having, but Anya, thank you for relaying it. And it relates to the idea that a lot of what goes on in the ocean is out of sight. If we see a satellite image of a rainforest that's been cut down, pretty obvious what has happened, but we don't really have that same sort of broad perspective in the ocean. And so the question related to this, and I think this one came from Marlene as well, is how to better engage on both the community and the national scale, including countries without large coastlines. And so how can we engage with them so that it really becomes a global effort to do better? Because as Ken notes, our sustainability as a species and a planet really depends upon it. Anya, would you like to say something on that one?
Yeah, sure. So look, I think there's a lot of issues around getting the international consensus together. We really noticed it at COP, that there were a number of, that the ocean was becoming more and more into focus, and there was a lot more people talking about the ocean than there had been in the past. So that was super positive. But I think there's a big step from that to actually nations getting together and doing something about it. That being said, there are a few places where action is happening. And in Canada, for example, they're working with the Commonwealth Blue Charter to bring sort of historically, politically aligned nations together to talk about what they're calling the blue economy. And it's really important to remember that the blue economy was originally developed as a concept for small island nations who felt that as sea level rise was increasing, their blue economy was being threatened. So it's been then that name of blue economy has then kind of been co-opted by a number of other actors, including major industry partners who consider things like drilling for oil blue activity, right? Because it's in the ocean. So we have to get our terms straight. But there are, so Commonwealth Blue Charter, certainly a place where Canada has started that sort of north-south dialogue. And I think that's, we're looking forward to some real action in that area. There's a couple of other places though. The UN, of course, the UNFCCC organized COP26. That's a place where big action can be taken. And it's a place where we can highlight the role of oceans and climate, as we did in the recent COP26 in Glasgow. And I think that's a very important place. The IPCC, which is the Intergovernmental Panel on Climate Change, does the really big science synthesis of climate change. And even there, the ocean, you know, about 5 or 6 years ago, a group of scientists actually had to go and lobby simply to get the word ocean incorporated into the IPCC report, because they were measuring changes in the atmosphere, but they weren't recognizing that the ocean controls climate. They were just measuring the changes in the atmosphere and talking about land-based changes. So the ocean has kind of been a bit of an orphan in the climate discussion. So, okay, so the Commonwealth Blue Charter for Canada, the UN and UNFCCC and some of the IPCC processes. We also have some other sort of alliance of nations, like the G7, for example. The G7 are kind of economically wealthy nations for the most part. And they're a great number of them are strong ocean observing nations. They're nations that have innovation and technological advancement in ocean space. So that the G7 is a good place to push this agenda. And finally, there's something called the High Level Panel on the Blue Economy, which is a group of 13 and now 14 nations. The US has joined up. They joined at COP, and that's an enormous boost for what's now, rather than called the high level panel, is now called the ocean panel. And I think that's the kind of place where you can have conversations with like thinkers and really move the needle. So I think there's a bunch of international fora where we can try and pull that together. The problem is, what about Switzerland, right? What about nations that are potentially could contribute a lot to understanding the ocean's role in climate, but don't actually have a coastline? And I think that's the reason that some of these international conversations are so important, just to raise awareness, is that there are nations that are landlocked that we urgently need to step up, because they're wealthy nations and they should be doing their bit in pulling the climate conversation forward. Even Canada, there's a lot of discussion on the coasts of Canada that because all our policymakers are in Ottawa, where I am right now, they don't actually have the ocean in view. So most of the population is in, Toronto, Montreal, Ottawa. They have beautiful rivers and lakes, but they don't have the ocean in view. So I think it's an uphill. It's a big push. It's a lot of work. But I'd say we've come a long way in the last 6 years. And if we all sort of join together and raise awareness, we can do a lot in the next 6. So let's watch the space and keep it moving.
Excellent. I noticed Marlene comments that Switzerland does have rivers, and it's really about water. So there, the water cycle, of course, is very much part of all of this discussion. One other question we haven't gotten to yet that I was going to throw back at you, Anya, is the idea of blue carbon and what that's all about. Did you want to say a little something on blue carbon?
Yeah, blue carbon is a really interesting issue. So blue carbon, as it's generally defined, is the carbon, hard carbon in our coastlines, usually the roots of, so mangroves, seagrasses, and kelp, the large plants that hold lots of carbon that are on our coastline. And there's been a lot of discussion about how important blue carbon is in our, the fight against climate change. And I would say a couple of things. First of all, it's very, very important that we get the numbers right. So we're not going to be able to measure the impact of blue carbon unless we're doing a good job monitoring the ocean and observing the ocean and observing these blue carbon communities. So that's a really, really important part of what we do. But also, I think it's really important to recognize that blue carbon is just a tiny fraction of the importance of these communities. These coastal communities of kelp beds or seagrass beds, or, in some cases, corals and mangroves. Those are critical biodiverse ecosystems that bring richness to the coasts. They have an environmental value. They have, in many cases, a cultural value. And in a number of cases, they're also very, very positive for the coast because they buttress the coast against storms, and they can dissipate the energy of the ocean in a way that's very positive for communities that are locally based on land. So the blue carbon, I think it's really important not to just have the conversation about the carbon. The absolutely critical carbon issue about the blue carbon communities is that most of it's stored under the sea, under the ground. So if you have a seagrass meadow, you've got thousands of years of carbon storage underneath that meadow. If you've got a mangrove forest, you've got thousands of years of mangrove roots going sometimes meters down into the sea floor underneath the mangroves. And certainly for seagrasses, it's been measured that they have meters of seagrass roots that are storing carbon for thousands of years. So the critical thing about blue carbon ecosystems is we must not disrupt them. That carbon has to stay locked up. Otherwise, it's the equivalent of another fossil fuel release, right? You disrupt the ecosystem, you get all those roots coming out of the ground and breaking down and releasing their carbon again. So it's more important to preserve what we have than to think about increasing them to the size where they're really doing a really big job on an annual basis of pulling in carbon from the air. To lock that down and save blue carbon ecosystems for the future.
Yeah, I mean, I would add that in addition to currently entering the decade of ocean science for sustainable development, we're also entering the decade of ecological restoration. And so there is some potential for restoration of some of the wetlands that we've lost over time, which again have released a lot of carbon in the process. I'm going to throw this next one at Emily, and it's maybe a little off topic for you, but see what you think. What Anya has talked a little bit about here are really nature-based solutions and a nature-based focus, but there are also a lot of engineering ideas, engineering-based solutions, and perhaps as an ecologist, I'm thinking you might have some thoughts about that.
Well, as an ecologist, I mean, the research that I'm doing on seabirds, we're really making an effort to make our research more applied in order for conservation. So one of the ways that we're kind of applying our work is that we are taking to the account of multiple stressors on seabirds, such as so work is looking at the kind of the foraging habitat of the birds in relation to shipping, and so looking at foraging habitat, but also looking at energetics. So we use something called GPS accelerometers. It gives us an idea of activity rates and where they're spending their energy and where they're foraging. And we're looking at their foraging areas, their energy expenditures in relation to other stressors, so such as shipping, contaminants, and temperature, but mostly shipping. But we're hoping to kind of use that information to create kind of risk maps of habitat that is important for predators versus like high risk habitat versus low risk habitat, where they're expending energy and where they are most likely to be vulnerable to disturbance. And we hope that these maps can be used in kind of marine spatial planning and to inform shipping routes. Where I am on Coates Island, it's very close to the Baffin Island line, so there's lots of shipping routes that pass through the seabird colony. And so through that work and through looking at multiple stressors, again, we're applying that to risk maps to inform to make it more applied and to help with marine spatial planning.
Yeah, I mean, two of the scenarios that have been proposed. One is somewhat near and dear to Anya's area of expertise, which is her area is not iron fertilization, but it's a proposal to try and remove carbon from the atmosphere. And then a second one is to pump concentrated carbon dioxide into the deep ocean, which is an area of great interest to me. And so certainly the risk assessment aspect of that is very significant. And I would say, certainly in the case of iron fertilization, I think the evidence suggests the likelihood of it being successful are pretty thin. Anya, did you want to say anything about some of these engineering solutions and the likelihood of success?
Yeah, look, I think many of them are still pretty high risk. I just heard that some of our American colleagues are thinking again about seeding the atmosphere, for example, with particles to prevent sunlight from hitting the ocean to reduce heat. And some of the models suggest that you might be able to block sunlight over one part of the ocean of the globe, but then you might cause a drought in India or something. It's a pretty nonlinear system, our climate system, and it's hard to manipulate effectively. That being said, I have to say I was involved in the first ever iron fertilization experiment in the Southern Ocean, and we did double the carbon flux by dumping a whole lot of iron into the ocean, which fertilized the plankton. Once you do that, though, you start to do your carbon calculations, and you calculate the amount of fuel it took you to get from Hobart, Tasmania, to south of the polar front and back again, and all the people and effort and even just refining enough iron to do that. The carbon cost of that doubling of the carbon flux in the Southern Ocean was enormous. So I don't think we were anywhere near on par, to actually have a functional system that you could actually say. Now, I think, though, that we have to realize, again, I mean, I'm kind of a bit of a mantra here, but I do think that we have to get back to that conversation around ocean observation, because I just noticed, those big wildfires that happened about, it was 8 months ago, I think, in Australia. There was a huge set of wildfires. The carbon dioxide from those wildfires, because the wildfires fertilized the ocean east of Australia, they quantified roughly that most of the carbon that was released by those wildfires was taken up by plankton, by diatom blooms in the ocean. So that was a natural experiment. So, it's not impossible. And people talk about this as being one of, 10 or 15 different small things we could do. So we might do a little bit of plankton fertilization, a little bit of blue carbon sequestration, a little bit of carbon dioxide removal through artificial means. And each one of those is a tiny little wedge, which helps us get to our climate targets. I think that my mantra here is simply quantify it, get the numbers, measure it against a relevant baseline, show us that you're doing the carbon sequestration, and show it credibly and effectively. And that means working with scientists. And many right now, we're working with an organization, a really interesting organization in the United States called Ocean Visions. And they've just asked the Ocean Frontier Institute to come and join them, essentially to provide that ocean baseline, because they're working with a large number of very ambitious carbon dioxide reduction sort of innovation companies who want to scale up quickly, a la Elon Musk and X Prize and so on, and blast through and really create this carbon sequestration in the ocean that's going to make the difference. And we actually talked to one of the foundations that's supporting some of this work and said, well, what's your ocean baseline? How are you going to measure that against the backdrop of this already very active carbon uptake system in the ocean? And they said, well, we don't care, because if you've got a fire burning, we're just going to build the biggest fire truck we can. We don't care how fast the house is burning. Get the world's biggest fire truck. And you know what? I had to scratch my head about that a little bit. And then I thought, you know what? There is a difference about whether you have the towering inferno or whether you have a haystack burning, right? Whether you need 64 fire trucks or whether you need one. I think I cannot agree that we don't care how fast the house is burning. We need to know this, because otherwise, how can we generate realistic targets for our land-based industries that have to make significant sacrifices to get us to net zero? And we're going to say we're going to give significant sacrifices to net zero, but we're not exactly sure what's happening in the ocean, so we're not really going to worry about it too much. But you go ahead and risk your shareholders ire by changing your economic model for your company. I think we have to be credible, we have to be quantitative, and we have to be science-based if we're going to get to net zero in one piece, essentially. To have a good, societally supported and an active dialogue across so many sectors.
Yes, and indeed, depending on the nature of the fire, one might want to send 50 small fire trucks rather than one massive fire truck in order to be effective in dealing with the problem. There is another comment from Marlene about another session. The research was about helping First Nations farm the kelp beds. And so I suppose I can't read the end of the question again because of the screen issue, but it does raise this idea of nature-based solutions and whether there's some potential there to work with different groups to improve the role that nature plays in carbon uptake. So I'm looking at the time. We have a little bit less than 10 minutes left. I don't know if we have any other further questions, but I thought I'd throw it back to each of you to ask whether you have any final thoughts you'd like to share with us. So why don't we go in the same sequence that we presented in. Anya, any sort of closing thoughts after this discussion you'd like to share?
I think this has just been a great discussion. I've really enjoyed hearing Emily and Ken's experience, particularly in Indigenous communities. And just thank you very much for everyone today for joining us. And it's been a pleasure talking with you today.
Wonderful. Thank you. Emily, some thoughts from you to close things from your end?
Yeah, great discussion. I think what's come up a lot is the importance of working with communities on all levels of research, particularly Indigenous communities that are heavily impacted that are coastal and impacted by climate change.
Excellent. And Ken, some thoughts from you.
Yeah, I said a lot more today than I actually thought I was going to say, to be honest. I find that I work with Indigenous communities. I work directly with Indigenous communities. And I have been for the last 10 years plus. And but the other thing that can be helpful too is working with local communities that are not Indigenous, other resource users. That is kind of important as well. There's a different context, mind you, because with Indigenous communities, there is inherent rights to lands and waters and resources, and there's always a concern that information shared out may not be used in the best interest of the communities themselves. But to try to get the best possible information in science is really, really important. One of the myths that I also think is kind of important to remember about Indigenous communities is that Indigenous communities also have economies. They also rely on resources. It's just that the approach, going back to the point I was trying to make earlier, is not always the end goal of research and science and Indigenous knowledge systems within a community, Indigenous community, is not always towards maximizing economic gain. There's inherently within the value system this need to find the balance between using our resources, but not doing it in such a way that it's going to have irreparable harm to the population, towards the habitat, towards other people. And that kind of value ethic is a little bit different than what goes on with our capitalist society, which tends to just look at resources as something that you can acquire. And I wouldn't even like to use the word resource because that implies that you can actually buy something, you can own it. But I know that if everybody on our planet lived at the same level that we enjoy here in Western countries, that we need 4 planet Earths to sustain us with the amount of resources. And unfortunately, we don't have that. We have a fixed unit. And I know people are trying to build colonies on Mars and build space stations and colonies on the moon, but really we are here on this planet, and we just have to understand that in some areas where if we're thriving in some areas economically, then or prospering with the words that they use, that there's suffering in other areas. So it's really trying to like balance ourselves and really like try to learn about our needs rather than our not just catering to our wants. That's kind of an approach that like it just keeps being reinforced upon me. But yeah, we have in the Indigenous communities, we have economies. We need things such as housing and shelter, clothing, transportation, and all these other things. It's just that there's just there should be a better understanding in our society that we shouldn't exploit things, that we should actually look at sustainable methods towards resource extraction, the way we interact, and appreciate that we are beings on this planet, and that hopefully the generations yet to come will have a fulfilling life like we get to enjoy, at least those of us on this forum there today.
Excellent thoughts, Ken, to wind down our session. A nice thank you there from Mark, which we appreciate. The very diverse perspectives that we've heard this afternoon, which I think are really quite interesting and very important. And so the ocean is missing was the theme of today's session. But I think we've made some good progress, at least among this group, to trying to put the ocean back into that puzzle. So thank you, Anya, thank you, Emily, and thank you, Ken. And thank you to the Canadian Science Policy Conference for giving us this opportunity to discuss this very important question. And last but not least, thank you to our audience for tuning in. And keep in mind these thoughts and that whole sustainability challenge. And I think we can all try and do better to leave less of a footprint than we have in the past. So on that note, I think we'll call an end to it with 3 minutes to spare. And again, thank you, everybody.
Thank you, Paul, for such a great job with the moderation.
Yes, thank you, Paul.